Hello, well, this is Chieh from Northeastern University. This is part 7 of the Spectral Clustering series. So in the last video, I think we talked a lot about the adjacency matrix, which when we represent data in terms of like vertex, the adjacency matrix give us the weights between them, the relationship represented in this matrix. Now, we also went over concepts such as degree of vertex, which if we do the degree of vertex for 1, we're talking about V1, and we're summing up the entire row. For V2, we're summing up the second row. So it's essentially the relationship of V1 with respect to every other node or every other vertex. Now, that's the degree of a vertex. So that's one single point. Now, there's also a degree matrix, which is essentially the degree of vertex lined up diagonally in the matrix. And the rest of the matrix, that's all just zeros. So this is a square matrix. Well, with today's lesson, we're going to go over a quick example to demonstrate some important points in spectral clustering. So here we have 6 points. As you can see, they're in blue. Here. So we have 6 points. And like if we were to look at it in the table format, it'd be like this. That's like vertex 1, vertex 2, vertex 3, on and so forth. So these are the points, and if we plot them out, it looks like this here, this right here. So visually, we can very quickly tell the 2 clusters apart. It's quite obvious that if there are 2 clusters, you organize them as this. Like we can just look at it, and we can split them into subsets. So one subset could be like an A, and then A naught. So A will be 1, 2, 3. A naught will be 4, 5, 6. 4, 5, 6. That's what I mean. So it's very easy to split them into subsets. Now, once we have the subset split, we can then label each one of them. So for V1, we can if we let 1, if it's in A, and 0 if it's in A naught. So if we look at 1, 2, 3, that would be 1, 1, 1 because they belong in A. Now 4, 5, 6 is going to be 0, 0, 0 because they belong in A naught. So this right here, F, we're going to represent as the solution, which is the labeling of each point. So it'll be like 1, 1, 1, 0, 0, 0. Then this would be the solution F. Of course, like this is a very simple example. It's really obvious, but we normally won't be able to just look at the data and determine the sets. We definitely won't be able to look at the data and automatically determine the solution. So instead, we're going to try using the spectral clustering approach by first calculating the adjacency matrix, W. For this example, we're going to use the Gaussian kernel to get W. If you remember from the last video, this is the Gaussian kernel here. Now, and we did some examples of calculating it. Now, if we were to go through each point, right, V1, 3, V4, V5, V6, if we were to go through each point and calculate them, you will get this. Right now, it is probably a good time for you to basically try calculating a couple of these, maybe even the whole matrix. Now, over here, I put 0 dot. It's actually not 0. It's actually a very, very small number, like 10 to the 8th or 10 to the -7th. So For all practical purpose, they're small enough to call them 0. So I'm just going to round them down to 0. And these values are also pretty small, but I'm going to keep these. But just keep in mind that when I say 0 dot, it's not 0. It's just very, very small number. Now, you should use this formula and see if you can get this like matrix. You probably want to pause the video and do that. So hopefully you'll get the same values. I might have made a mistake, but I think this should be fine. Anyways, now once we have calculated the adjacency matrix, we still don't know the solution. We want to know what F1 is, F2 is. So F1 is the label for V1, F2 is the label for V2. And we don't know if that, I mean, obviously from the previous example, we know it's 111,000. But let's pretend we can't see it. So right now we don't know. So how do we find the clusters A and A naught? Well, one way we can find it is like philosophically, we want to find a solution F such that the relationship between A and A naught is minimal. Like think about it. If we have this here, right? The relationship here between them are very, very strong. So it doesn't make sense to split them up. However, the relationship here versus here, these dots are very weak. This is a weak relationship. So it makes much more sense to separate it this way rather than separating this way. So I can't make this point more important. Like this is a very, very important point. The whole point of spectral clustering, the point of spectral clustering is to find the F solution such that minimizes the relationship of the two clusters. Ideally, we'd want like no relationship. So it's very clear that this is one cluster and this is the other one. But there are noises, there are other things, so there will be something, but it'll be a lot weaker. Okay, now I'm going to argue that if we want to find a relationship, we basically have a solution F. And from the solution F, we want to get some kind of measurement. We'll call it R for relationship. And if this R is a large value, it means the relationship is strong, which means the clustering is bad. If this R is a small value, it means the relationship is weak between two clusters. Now, if the two clusters' relationship from each other is weak, it means the clustering is good. Okay? So if we can somehow get this value from a solution, then we can evaluate whether our solution is good or bad. Okay. Now, the way to do that, I argue, well, in spectral clustering, is this equation. This equation is essentially gives you from a possible solution of F, it gives you a relationship measurement. Now, again, you might remember that this was the solution. Let's somehow miraculously we pick the right solution. Okay, we are doing it complete randomly, and somehow we pick the right one. How will we go about calculating this relationship? Well, let's see. We have to go through every single element to calculate this. So let's start with W11, which is this one here, W11. Now, let's write here, W11, and then we have F1, which is this, which is 1, minus F1. So this will give us a square. This will give us 0. The next one will be W12, and then F1 here, F2 will be here. So it'll be 1 minus 1 again, 0. Now W13, again, 1, 3. So it's 1 minus 1 again, 0. So basically, what this equation is telling you is if they belong in the same cluster, you're going to ignore the Wij value. So basically, here's V1, V2, V3, V1, V2, V3. You're going to ignore all these. You will only consider them when you have, like, for example, W24. So 2, 4. So this one, this value right here. If you do W24, you have F2 minus F4 squared, right? So you have W24, which is 0.0002. F2 is equal to 1 minus F4, which is equal to 0 squared. So this will give you 0.0002. You get this when the two of them are different in different clusters. So what this equation right here is telling you is the summation of all the values, all the Wij's that belongs in different clusters. In other words, it's the relationship, like it's the summation of these relationships. Not the one within, but the one like right here. These ones right here. The summation of all the relationship between the clusters. Now, you want to make sure you go over this and really study this relationship. But this is what we want. We want a way such that we can evaluate the result. The answer. If we evaluate a possible solution, again, and we get an R back, which is some kind of relationship measurement, we want it to be as small as possible. And now, if we were to calculate this, we will end up adding these numbers up. If we add them up, it's right here. We get a very small value. And that makes sense. We want a small value because this is the right solution. Because this is the right solution, we got a small value. Now let's pretend, remember we were picking them randomly. Instead of 1, 1, 1, 0, over here we'll mislabel this and say 1. So this is wrong. Well, not wrong, it's just not the best solution. So we picked this. And now if we were to go and calculate this again, so the way it would have worked is it would have said that this whole thing was in a cluster and this was in a cluster, and you would have summed up this and this, because they're the one like not in the same cluster. So if you have done that, you'll get this value. Now compare the difference. Wow, this one, I mean, it's a lot, not just a little bit. It's like how many times bigger? 10 times, 100 times. One second, one. It's like 100 times bigger. So it's very obvious that when you have something that is, I won't say mislabeled, but when you don't have the optimum solution, you got a large value. So this is a very good way. Now, I mean, we can randomly pick this like F with some ones and zeros, and then evaluate them. I mean, we can do every permutation. Let's just try 1 0 0 0 0, 1 1 0 0 0 0, 1 1 1 0 0 0 0. I mean, you don't want to do that, but you could literally just keep picking this value and then pick the one that's the smallest. Now, I want to reiterate this. This equation measures the relationship between two clusters. And we want to find like a solution such that this expression is just as small as possible. And that's what we're trying to do. Now, we want to mathematically formulate this. So the way to formulate this is we want to find the argument. I mean, this is the way you will formulate. You want to find an argument f in here such that it minimizes this expression. So f, remember, is this whole f1, f2 thing. That's what we want. And this is the whole point. Well, from one perspective of spectral clustering. Now, I think this is probably enough for today. We have there's probably maybe 1 or 2 more videos to go. We still need to go over the derivation of how to represent this in a way so that we can solve it, and maybe do some examples. So you want to probably go over these concepts, especially this equation. This is so important. Like, this is basically the whole point. If you understand what we're trying to do here and why we want this to be as small as possible, then you understand like the point of spectral clustering. And wow, we've made a mess of this. In any case, well, this is Chieh. I guess I will see you in the next video. Bye bye.